So one of the ambitions of next generation risk assessment is to move away from the use of traditional animal tests. And the project is primarily focused on understanding toxicity, primarily at the molecular level. And if we could catalog the bioactivity, the biological molecular responses of exposure to hazardous chemicals that are also indicative of particular pathways that are associated with adversity, one day we would be able to make decisions and regulate based on observing those pathways as opposed to having to observe harm because of traditional animal tests. One of the most important attributes of precision talks is that we've brought together the right people. And we did so well over a decade ago, where we understood that the challenge of doing next generation risk assessment is a multidisciplinary challenge. And that means looking out for some of the very best in the world in toxicology, obviously, but also model systems biology, molecular biology, big data science, lawyers, policy experts. Bringing the right people together makes managing the project just that much easier, but also that much more rewarding, because although we may actually be experts in one thing, we're not experts in everything. And every day from this project, I get to learn something new. I think that one of the most important attributes of precision talks is that it draws upon evolutionary theory. And I think that's quite novel. If you look at it in terms of animal phylogeny, you realize very quickly that you may be observing the same phenomenon across all these species, making prediction of toxicity a lot more exciting and interesting because it is by evolutionary descent. The other aspect is, of course, technological. We are data-driven in terms of a project. We create a lot of gene expression data through RNA sequencing. We produce a lot of metabolomics data. And in combination, this gives us a very good indication of biomolecular pathways that are important when an organism responds to a toxic compound. But maybe there's even a third one, the innovation of marrying the science with law, and to craft the experiments and craft the objectives of the project, specifically around areas that could easily benefit either now or later from a mechanistic understanding of toxicology in order to make regulatory decisions. And so maybe there are three very key aspects there to consider in terms of innovation.